Hi everyone. Hi everyone. I hope you are still awake. Lunch, right? Usually this workshop and it's taking eight, and we need to just fit it in 55 minutes. So, challenge today. So, how many of you know a library called Fastify? Then you are place. Let's start with it. So Fastify, I give you like show what Fastify is. Fastify is web framework built with mind, and speed is definitely at the core. And another interest of Fastify, definitely the plugin architecture that is at the base. Fastify is a nice agglomerate of few libraries. One of those libraries is Find My Way, which is the router. And Find My Way is used by Netflix, for example, to run their entire platform. I had to do some tricky part to Fastify use Find My Way. They got it. So to check the web Fastify.io. Find a little bit of documentation. I have to say that we are working implementation heavily. However, it's still a little bit. But at the core of Fastify, is find the problem, write a PR. If you want to contribute to the document, make a nice PR. And plus the source code is well written. So in this 55 minutes, I want you to simple journey out simple HTTP server with Fastify. And in the spirit source, at the workshop, I will move the repository with all the slides and all the exercise public, so that you can continue the workshop if you want. I'm going to try to go a little bit fast on the initial pieces, that we can dig a little into the plugin part. And the last is all about integrating plugins like Mongo and authentication. I don't think we're going to really touch it, but you will open source the repository. So we'll see exercise. Sanity check. All have Fastify in your machine, or Node at least. Do you have Node? So easy thing to do is to enter Fastify, so that you can get the library or working folder. So through the generic structure of an HTTP server. So Fastify is Express or Happy or Seneca framework. But what you can once that you create the instance with options, and in this case we just to true. Behind Fastify is called Pino. Check it out; it's super fast. And the way actually register routes is very common. In other web framework. So you define path, and then you define handler. So of Fastify is, you can see by the syntax that at the core of Fastify there is a sync await. So main difference with Express, that does not have a sync await as a first-class citizen of the framework. Fastify is all built around promises and async await. So that's why the performance are extremely high using async await, especially after Node 6. And like any other web framework, you just need to tell, hey Fastify, just open port in this case, start listening. And because it's all based on message chain, catch, or else you get an handle exception. Make sense till now? It's very forward. Just forward. Just. How many of you have photographic memory? Let's see. Good. Big photographic memory. You can basically almost all the exercise. Just remember. But don't take. The interesting thing of Fastify, that behind the scene of Fastify, streaming architect. So you can have async await. You also have streams behind the scene. I think the difference between hub temple and the frameworks is the fact that anything inside of Fastify is a chainable, which makes async operations and streaming extremely funny and easy. Like in this case, for example, we are a file from the file system, and we can return it as a stream. Consumer. So the other interesting thing is, and plus this slide is, I should put a disclaimer. I would not really recommend doing that, but because we all know that static files should be served by Nginx or a CDN, right? We all know that. But Fastify as a kind of foundational piece of can serve because of string and because of his static files and apps also serve extend efficiently with zero memory footprint. Amazing. However, I would never for you to serve a static Fastify. Or let's last and more interesting. So we are all trying to PIs, right? So okay, I understand that the same thing as Express, but is help me building APIs. That's, I think, the most interesting Fastify. That is how JSON and validation are of the whole library. So in this case, we are just returning an object. So the library is not returning. So different Express returns JSON as a primitive. And let's try something done. So let's build a simple HTTP that returns a JSON object. If you want to try, it should take you, for the people with photographic memory, probably 30 seconds. For whoever doesn't have photographic memory, I can give you a minute to think, and then I can show you the solution. Kind of data that I have ever used, I feel lacking when you search. I can never use it. Today is my day that I feel want to try to launch my stuff Windows terminal with the solution. Last time it to the machine, so you need to cross. So let me open. Can you see my black screen? So as any of you was able to build a basic server? No? So I should check the Fastify.io website, how many people are clicking on the web. I opened one. No code. Sorry. So if we were to build a beautiful web service, and I try to take a step ahead just for the sake of time. In Fastify, you basically just declare the Fastify instance. You would basically just do something not so fancy like get, and then you would have like hello, and then you could just do something extremely simple like this. Return. It was writing in Italian. So this is the basic return of JSON in Fast. But as you can see, Fastify adds a little bit of meat on the fire. Is the old schema bar. So let me take you back a little to our presentation. See, announce the web service with interesting schema validation. So if you are familiar with validation, JSON schema validation, how many of you are using it? If you are not using it, it's bad. And I tell you the reason why. Because actually one of the most interesting parts of Fastify or using JSON schema, right? Behind the scene, AJV. Familiar with AJV? The JSON schema library. JSON schema basically tries to represent the request and response object. So are you familiar with Swagger or OpenAPI? So imagine to have the power of Swagger into your web service. And you say, I declare my schema for my request and my response, and my service is going to make all type of validations on the inbound and outbound schemas. Let's take a step only on the inbound schema, right? It can be a query string, it can be the most interesting is that in this way you're gonna kind of avoid your ability to run and execute the handler before validation of the payload. So in this example we're saying, hey, path. There is a query, and in this string we have an object name, and this one string, and if value defaulted with world, and this string parameter is also required. In this case, what it does, there are as a hook structure in the scene. So if you look at Fast is a very deterministic model. How the events are then executed from request to we can go later. You can check right. That's actually one of the part of the library. Whole hook structure. Before the request kind of handle, the JSON schema validation is ran. And in case it doesn't pass the validation, the event is now propagated down the chain of hooks, which means that you will never call your handler. Now, the interesting part of this is that you are going to make your service way more resilient because it becomes more fault tolerant. And at the same time, it makes also a clear separation of concerns between the definition of your HTTP and the handler itself. So there is also a library schema. Are you guys with schema? Hey? No? Familiar with Joy? So basically the same thing, right? So represent with an object chain, JSON, and in this way that the JSON object is the schema object that you need to validate. Instead of representing as a boring object, you can just represent it as a class. So if you look, we are representing the same thing of validation, but chainable. So now why should I use Fluent versus schema in format? To be very honest, Fluent schema is way more declarative and way more concise when you try to basically write very declarative, let's say, object definitions. On the other side, JSON schema is a very bare-bone object, allows you to have more flexibility and extensibility in terms of maybe pre-compiling it. How many of you are using TypeScript? A couple of people. No? We're at Microsoft, all raise hands and say, yeah, we all use TypeScript. So if you think you could have DTS files generate this kind of with some relation magic, so just to give you a preview, we are heavily Fastify to migrate and the interface for the schemas to TypeScript of being purely JSON schema. But you need to wait 6 months on our release. Not the request, but also the response, right? And I think the most interesting part of the whole object definition for the request response object. Much as you can declare inbound validation, also the other can be defined. Or in this case, for example, the object we expect to be a clearly HTTP status code 200, and object must property call which contains a type string. Does it make sense? So we take a journey back 20, 30 years. We go at the time of enterprise service bus, and we are rebuilding it in 2020 with Node.js. We have inbound schema validation and outbound schema validation. What is the big advantage of using outbound schema validations is that you are kind of changing the way you are designing your microservices. So you are moving from a loosely coupled kind of with microservices that they contain, and they basically all the contracts, declarative and more distributed way of having base microservice architect. I know that it's kind of holistic, but if how many of you are familiar with that? More than TypeScript. WCF was grandfather of base communication with the service contract and the data, and what we are trying to Fastify is to re-represent contract model and service model, right? But in a more kind of JS, JavaScript base way. So a very important of all this validation round trip that behind the scene uses a open source called Stringify. Have you ever heard of it? People heard of it. What happened behind the scene and how Fastify is super fast is that Fastify uses both contracts that we just saw, so the request contract and the response contract, to define volatile in-memory schema to fast serialize and deserialize JSON objects. So when I told you that is mostly contract-based, you know, how many of you like Italian food? Okay. So next time, instead of having an open source, a nice cooking. So from an accent, I'm Italian. I love it. And we say that to make a perfect tomato sauce, you need basic ingredients of very high quality, and you put them and mix them together, and you have the perfect sauce. Look at Fastify is basically an Italian. They have a lot of organic, well-grown, like all open source, and they are stitched together to create features like fast JSON Stringify need to have schemas, understand how to serialize objects. In order to do that, well, if we have a contract base, automatically more inclined to write schemas, so we can the serialization of objects in the. It's like a tomato sauce, right? Tomatoes, onion, oil, a lot of oil, I'm not gonna tell you the secret ingredient. Let's try to build a schema to the route. So if you build something, I give you 2 minutes to add a schema. If you have something on your machine and you want to try, or else I'm going to show you part of the solution. Sorry, I was double checking that I was opening the right Visual Studio Code. Can you see the font, or is too? Can you see the font, or is too? It's too small. Now. Okay. Okay. So I'm a Vim user, but I miserably failed to have running on my Surface. I may use it because the escape key is terrible. I don't want to complain here in Microsoft to change the key. But if anybody wants to listen, an issue. Okay, let's do step back in the beautiful service and to write. Added a schema, right? A schema, as you see, we just Fastify route definition, allowable argument clearly, and the argument clearly, and argument after route definition. The route is a complex object contains the schema. In this case, we are saying a path. We are gonna send you a query string parameter name, which contains a value of type string. So let's try to think a little bit what's going on behind the scene here, right? So what happens is that I give it a schema, and automatically I am able to call that query parameter as an object property. And if I try to call type this name property string. What happened behind the scene is that we use the serialization with stringify, and it's the serial to detect the type from the query string, convert it into a strong in the query object. Some time ago I explaining this thing to a group of people. Some people, they told me, "Are you reinvent?" And it was like, yes. This one is more appealing, right? Because script is just vanilla JavaScript. End of the day, we just shade strong type object because that's how we try to look for a second into fluent schema will look like. So we already saw it. With fluent schema would be basically the same exact story. The only big difference is that fluent schema, in this way, we are going to declare the same thing that in the other file we had in a JSON object. So not a big difference. And the end result is going to be exactly the same, right? So we can access the property name from the query string object. And let's take a quick journey into looking on how we would do it a little bit more interesting and complicated. We just said inbound, so it would work exactly the same as in the slide earlier on. And if you were to add more more types or objects or more prop to this, you could just change. I don't know if actually TS type. Oh yeah, doesn't work. I wish the IntelliSense could resolve all that. Unfortunately, it doesn't. Can actually expose every single primitive type in JavaScript with the same exact library. And I just migrated the wrong stuff. there is that find the inbound schema and outbound schema, I will actually optimize the serialization of your objects, that handler. Continue with everything. Does it make sense? It's crazy. Do you want? Yeah, so it is around a factor 10 compared to Express. So Fastify can run in the latest version, 28,000 requests on a single node. Now, truth has to be told, we are running the test exactly on that Hello World example. Not a super complicated object. There's something that that Matteo, Mr. Fastify, experimenting. We are actually seeing a way for which we can improve the speed of station based on learning about the object serialized. So we already, how many of you are doing servicing with I React the last half an hour React, but I think it's the interesting point to discuss. Because it's to the serialization part. When you do server-side React, to take the DOL and serialize it into. So this process is CPU intensive, and what happens is that your event loop gets blocked. And how many of you are familiar with the event loop in Node, by the way? Deeply? Okay, so for the rest, Node is a single-threaded process. There's nothing exceptional. What is behind the scene is something called libuv, that is a magic library. Handles a glorified needs to be run. So what happens is that people think that Node.js is purely synchronous. In reality, what is synchronous is the queue is executed. So when you try to a server-side React component, any server, right? Because clearly you need from whatever HTTP. What happens is that renders that is basically a glorified toString, keeps the event loop until it doesn't hit the serialization, the object, which means more HTTP requests are coming in. They're going to be piled up into this queue, and your service will become super slow because Node needs to resolve all the objects that are in the queue before moving to the next step. The same thing happens with JSON serialization, right? JSON serialization is a purely synchronous process within the event loop. So what happened behind the scene is that with the fast JSON stringify, we are basically generating a templated string behind the scene. Are you familiar with templated strings? So just to refresh, templated strings are just basically a long string with a lot of placeholders, and JavaScript is able to replace the placeholders with n number of arguments. In this way, that particular string is going to be cached into the V8 execution. And that's why we can get that factor 10, because based on the two schemas, we generate templated strings for the inbound and outbound objects. So the serialization and deserialization, they can be super fast because we already know the object structure. While, as you know, JSON stringify and JSON parse, they work on a structure unaware model, right? They don't have an AST to traverse. They don't know a structure. It's a pure recursive function that goes and loop into the object and build a string, or the other way around. Funny thing, the curly brackets are the separators. Yeah. You mean in Fastify, right? Oh, yeah. If you handle the exception in, Fastify has embedded the unhandled exception part. However, as you know, you always need to, there is a library called Make Promise Safe, written by Matteo Collina. And this Make Promise Safe basically adds a global try-catch to your promise handler. So that one, there's nothing we can do in Fastify or in any other library, because it has to be even before the instance of Fastify is created. Right? It's a global object that needs to be registered. So that one, if you don't have an handle promise, that's the only way that you can catch it and handle it in a different way without making the server crashing. When there are exceptions within the Fastify process, all different handlers, they have an automatic catch, which return a 500. That's the basic behavior of Fastify. I mean, the fact that you are building an async function allows you to chain catch or to handle that exception within your handler. Well, I don't have any example with a promise, but the promise is going to be exactly the same, right? So what happens behind the scene is that your promise gets resolved, and we attach a catch to that promise, just to avoid that when you throw it, it's going to tear everything down and doesn't give anything back to the user, right? Because the biggest problem there is that you're going to end up with a timeout instead of an error 500. That's the main issue. Yeah. No, so it's going to throw directly. It's going to do an invalid request. Yeah, yeah. So it was a very conscious decision, that one, because then you enter the world of circuit breaking, and the biggest issue with circuit breaking, especially error 400, is that error 400, they are by definition, by HTTP standard, they are non-retriable automatically. So you basically go into this infinite loop of having a useless circuit breaker. Fun enough, in my personal experience, it's very complicated for developers to understand the value of having a schema. And, but as soon as developers, they start writing a schema in Fastify, I don't know how, but magically the 400 errors, they are dropping. And it's mostly because of that kind of contract-driven communication that there is always between consumer and producer. It's actually one of the mysteries behind Fastify, why defining the schema allows people to reduce the number of error 400. However, the error 500s, they grow massively because clearly you have people that forget to write a catch, or they throw instead of returning. Yeah, so that's a little bit the mystery there. Okay, any other question about the validation? Don't you want to validate something? Sorry.
So it comes out as like you have like an array of objects, and like Fastify is going to shine. Or it doesn't matter.
Oh yeah, no, sorry, I was telling you about the part. Sorry, I completely forgot. I got dragged into other stuff. But yeah, so Fastify can actually shines in both cases, right? Both on the array side and both on the single object side. So in the single object side, it's kind of interesting because, and that's a magic behind V8. V8 is going to cache that object for you until the garbage collector is not going to mark it as disposable, and then it's going to be trashed. But as you can see, when you have a route, the route becomes very static. So the object structure on its own is going to be always very static. And so that kind of string template is always going to be cached until you don't kill the whole process. It's going to shine when you have an array of objects, way more than a single object, because the performance impact is exponential to the number of objects in the array. The other thing that if you want to test with the JSON schema, oh my God, with the JSON schema serializer is actually that if you have an array of objects, it magically gets also faster. If all the objects are exactly the same, it gets exponentially faster. But the average is 10x to express, around 7x to happy. The latest happy is extremely fast. So we actually saw that it's probably around 3x the speed of happy server. Okay. So interesting part is how do we test a REST server? And I think this one is one of the nice features inside of Fastify. So as you know, we all need to write tests. And there are many tests, like test framework like Jest, for example, or TAP, you mentioned. The only main challenge that we always have is that in order to test my service, I need to find a way to start an instance of that service with certain values, certain properties, in order to be able to run my programmatic test. And if you remember, Fastify is a global instance. And that's a problem, right? Because when you're running your unit test, you want to tear up and down your instance continuously. So the challenge is, how do I create a factory out of a singleton, right? Because imagine, you remember, Fastify is basically const Fastify equals Fastify, require Fastify, and generate an instance and pass an object with options. But that one is a global object. That's how we register all the different routes, how we register the listen function, and so on and so forth. Anybody has an idea on how to create a singleton? A factory out of a singleton? Let's see. Let me go to my, I'll let you think while I'm going to explore my terminal, which is going to take. Let me see if I left it here. No. Okay, let me do some cleaning. Oh, I was missing the Windows noise. How many of you are using WSL2, by the way? Oh, okay. I was just telling you that WSL2 is great. It only has a downside that sometimes crashes, and Visual Studio Code doesn't like to keep hanging the server, so there's a high possibility that I need to open Vim. So let's start with oh my God, updates. Okay, so you remember that we had our Hello World API, right? And before, we had the Fastify app that was just a global object. So if you remember, Fastify before was declared in this way. Right? So I just instantiate Fastify with, is it big enough? Sorry. Because maybe I'm losing the settings from closing and opening over and over again. Basically an option object. But because we need to create a factory, and basically we need to create an instance that we continuously regenerate over and over and over and over again, this one is the way you can create the factory. So if you see, we have a function that gets our options. It creates the instance within these functions. Business as usual, still works. And the only thing that we do at the end is to instantiate that constructor that generates and returns an instance of Fastify. So it's very important to notice that at the end of build, we return Fastify so that we have the instance at hand ready to be used. Does it make sense? Yes, no? Maybe so. But why do we need to create the factories? Just because when you write a test, it's always great to have the server disposable at hand. So how many of you are using TAP for testing? Jest? Do you like Jest? But you could React also. Have you ever heard of TAP, by the way? No. So TAP is it's actually a very good testing library. I say that it's good because it's super simple, and I always tell to everyone, if I can write a unit test with TAP, everyone can. I'm famously for being always I love writing tests, but I also don't like to write tests because I find framework too complicated sometimes. And TAP is very simple, it's very linear, it's very declarative. It was written by Isaac, NPM's creator. And as you can see, TAP allows you to define some sort of, like in every library, clearly some, let's say, preconditions and pre-actions to be executed before running the test. In this case, it's kind of interesting to see that we are requiring our beautiful server. And why do we require that server? Because what we are testing in this case is like, okay, let's see if the hello world use case works, right? So I am creating an instance of my server, right? That it's here. And what I'm doing, I am checking that the response contains an object called hello, an object with a property called hello and a value called world. And as you can see here, there is something very interesting, server.inject. Let me go and show you some of the basic version of inject. So just, I mentioned before, as you see, this one is unfortunately required, very annoying things to put in every server, but yeah, unfortunately, promises are not saved by definition, so we need to register the global catcher. And the nicest thing of app inject is that inject is a functionality that Fastify exposes to allow the injections of requests within the framework. So if we go back to our test, what we are basically doing here, we are saying make a call to Fastify and to the /URL and hold on the response. And then as you can see, we just compare the response to the expected value. So inject is a great functionality to do mocking, to do route injection. So you could, in theory, with inject, you could write more complicated thing, right? So you remember that we had a validation on the query string, right? So you could, in theory, append whatever you want, and inject what it's going to do is going to simulate the request from within the server. Does it make sense? So if you were to make an HTTP call from the outside, you are still not testing completely the service. Right now, what we are doing, we're telling, take the service instance and try to inject this request within the server itself. In this way, you can basically write purely atomic test for your service. Does it make sense till now? A little bit? Okay. How many of you really like to write unit test and integration test? Because we are hiring in Talos, if you want, and to write tons of unit tests. Let's continue with our journey to try to understand a little bit something inside of Fastify. As you can see, this one was the example. The nicest thing, like I was telling you about injecting an HTTP request, is that we can really simulate an HTTP client within the server itself. And not only, I don't remember the name of the library. I just lost it. I had it in mind to simulate a ghost request within your service. But basically, we embedded this functionality within Fastify itself. I already told you that TAP is probably the leanest library for writing unit tests. You can also write integration tests with TAP, but I mean, if you are interested to see integration tests written with TAP, I can show it to you afterwards, because I need to open a private repository, and if this talk is recorded, I might have troubles. I already showed you a route. I want to just jump in the last 10 minutes before Chris comes here and chops my legs. I want to show you something that is extremely important. So first of all, one thing I want to say, how many of you are writing mocks for testing your service? Just don't do it. They are a pain to maintain. Most of the time, people, they think that the service is up and running because they have their own mock. The best thing to test microservices, so how many of you are writing microservices? A monolith? Are you writing something during the day, like a diary or something? So when you're building a microservice architecture and you're going more into distributed, and you're more, how many of you have heard of service mesh? Nobody. Well, service mesh is basically this horizontally highly distributed system with all services that are working independent from each other, right? So it's taking microservices to 2020. If you have mocks, you're actually basically not really testing the mesh on its own, so you're not testing that kind of interaction between the different services. Inject was actually designed to basically solve exactly this problem. How can we test microservice and distributed architecture without using mocks and still simulating interaction between services? Also because we cannot, you cannot write integration tests, because then you need to spawn Docker, and then you go into all the network thing, and then you're not testing really your service, but you're testing the network, which it's an infinite loop. And plus, you have also third-party dependencies, right? You're building, for example, a system that is using a database, then you should also test the database, and it's never-ending story. With Inject, we can even simulate the connection to a database. So one of the interesting part, I'm going to skip the database part because I don't have my Docker up and running. Due to a Windows update. Once again, I'm not criticizing Windows, great system. If it only stops to updates every 5 minutes, would be great. The nicest thing behind Fastify are just the plugins. I have 5 minutes, right? 1 minute. Are plugins, right? So why do you want to use plugins? Because when you are building an application, you are mostly building a monolith. And you end up in this infinite series of meetings with your team on how you can separate the concern, right? So separation of concerns, more how can I distribute the workload, and how can I reuse pieces here and there. And Fastify was designed on top of a plugin engine. And so everything in Fastify is a plugin. The only Fastify himself is not a plugin, but everything that Fastify encourages to use are plugins. And so the inject functionality becomes very interesting because you can inject inside of plugins. So I could inject inside of the Mongo client the information to simulate that connection. So plugins, they are actually very, very simple. If you think about plugins, they are this kind of self-contained instance of Fastify, which is passed by reference. And inside of plugins, you can still use all the fancy things of Fastify, like registering other plugins, right? Because you are building an AST with all these plugins chained with each other. You can add decorators and hooks that we saw in the beginning. And at the end, you can add routes. 1 minute. Another minute. Okay. So just to run fast, imagine that we are building a graph with all plugins, and that's how Fastify handles the chain of connection between plugin to plugin. And it's a deterministic model. So if you are interested in some mathematical crazy thing, it uses a deterministic model behind traversing this cyclic tree. And plus, we guarantee 100% of encapsulation. So when you have a plugin inside of a plugin, the context of the first plugin, it's guaranteed to be atomic compared to another instance of the same plugin outside of the containing plugin. I know it's a matryoshka kind of effect, but it's easy to explain. Well, I think Chris is going to chop my legs. But what I'm going to say, just check the continuation of this talk on my GitHub. You can find me on GitHub on Luca Maraschi, very simple. And the talk is called A Day at the Garage on my GitHub. So you will find it there on my GitHub. So you will find, and check the plugins, by the way. Plugins, by the way. That's it.